Right, around 1960. Okay, found unexpected behavior in apparently simple equations representing some airflows. Okay, some whenever he ran with the same inputs, different outputs resulted without any. Okay, so that's the unexpected behavior. So that's the behavior. It's some different results every time. And the tiny, okay, so it's giving the reason why his findings marked a seminal moment in chaos theory. Okay, so he found the reason, and it was because of, it helped in the development of chaos theory. Okay, so this is good. This is good to understand. To understand how unpredictability can arise from. Okay, to understand how how I think this is saying to understand how different outcomes come. Okay, as the same blah 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 blah. If instead of both flipped over, such a system which, while still technically chaotic, enlarges initial differences in position. So this is giving an example of unpredictability. That's P2. Chaos, machine mixing. And I think that's unchaotic. That's so there's unpredictability in non-chaotic. And I guess there's unpredictability in chaotic. Chaotic. I guess this is P3 is talking about chaotic system. What about it? So is there unpredictability in the chaotic? This is all details, obviously. Any early diver. This is all details, blah 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 blah. It is sensitive and not true randomness that generates unpredictability. Aha, so there is unpredictability. So there is unpredictability in chaotic and unpredictability in non-chaotic systems. Of the butterfly effect, I don't know what that is, but what's weather? Causes hurricane, the weather. But the precise state of the atmosphere. If you believe that we will ever be able to predict rain or shine for a particular day, years in the future. So you can't predict. So that's why there's unpredictability, and it shows in perhaps. So there's unpredictable, and it shows because we can't predict with full clarity those the weather maybe 2 years from now. I think the goal of this passage was to just introduce ourselves to unpredictabilityness in chaotic and non-chaotic. I think that's why. Explain complicated certain phenomena. Trace now. Historical development now. Distinguish a mathematical performance often now. Spread from one field of study. Describe the spread of a technical model of one field to other. Distinguish a mathematical pattern from its opposition. I don't see any double fields over here. That's why I eliminate D. Maybe C. I think mathematical pattern from its opposition. No, this is too specific. Trace. There is no trace. There's only one. Explain the of a certain of. I don't think it's explaining complicated aspects. I think it's C through POE. I think I'll select C because the others are wrong. Explain complicated. There was no explanation. It was just, frankly, telling us. There was no tracing either. Describe the spread of a technical model from one field of study to the other. But there were only maybe D. I mean, I think it's between C and D. E can't be right because you're not contrasting weather phenomena. Distinguish a particular method from its opposite. Describe the spread of a technical model from one field of study to the other. Distinguish a method. Of a technical model. Maybe D, but it's between C and D. Distinguish a method from its opposition. Maybe D it is actually. Because you're talking about the weather, you're talking about dough, you're talking about poppy seeds. I think maybe it is D. In the example discussing that which is true about poppy seeds once the dough has been thoroughly mixed. Ay, ay, ay. By attraction and repulsion, the dough is stretched. Wait, is it random? But this is so. It is not random. It is so there is some method to the madness. Systems fundamental equations. Okay. Any early data. For the separate ways. Unpredictable is it is the sensitive of which one also whether very indifferent. No, this can't be. They scatter random clumps throughout the dough. I don't think so. In fact, there is a depend. In fact, it's the opposite. There is a sensitive dependence on initial constraint. They're accidentally caught. They're accidentally caught. Yeah. I think their positions are dictated. They're bound to regulate this point attractors. Their positions dictated by the underlying equation that govern the mixing process. I'm not sure. I think between D and E, I'm not sure. According to the rounding errors and okay. The tiny rounding in this number mushroomed over time leading to erratic results. C clearly. Mushroomed over time. Let's see. Before the passage mentioned these are the five things. Except for do, yes. Yes. Oh, maybe not. Probably not right. So that is mentioned over here. Maybe not D. I think D. I'll go with 4D. It can be inferred from the passage which of the following pairs would most likely follow typical pathways within a chaotic system. I think there's both attraction and repulsion. I think it's E because there's attraction and maybe it's E.